Yeah, today I'm excited to be talking about active learning, a topic in computer vision that for years has been relatively complex to implement, and with some technology that RoboFlow's been working on over the past few months, can be integrated into your production deployments in a matter of hours or an afternoon. So this presentation is about building active learning workflows with RoboFlow. So what is active learning? The fundamental premise of active learning is to use data from your production environment to either bootstrap the creation of a new machine vision model or to improve an existing one, mitigating data drift that Jacob mentioned earlier. So the fundamental idea behind active learning is you capture production data and you run inference on that data using either a model you already have that you want to improve or one of the new foundation models that have come out, like Florence to SAM to other models, and to use those predictions, save them in your data set alongside all your other images, and retrain a future version of your model with new images. And using this approach, you essentially get labeled data for free that is adapted to your domain, rather than having to worry about manually labeling bounding boxes for the next 500 images for your dataset. You can use active learning. And then active learning is just part of a production deployment. So you can run inference, you can do all the same post-processing you do, all your business logic integration, anything that you need to productionize your application. So this graphic shows kind of that workflow from capturing all the way to post-processing and working with your predictions. Active learning can also be adjusted to run conditionally. So your active learning pipeline can run only for predictions that have over a certain confidence level, so over 50% or indeed under 50%. If your model struggles to identify one class, you can get all those lower confidence predictions, send them into RoboFlow for manual data review, and approve and reject them based on their accuracy. And so over time, you can improve your model. So why active learning? I kind of touched on this on the last slide, but firstly, you can use it to bootstrap data labeling. So RoboFlow has a couple features around automated data labeling. Active learning can be considered a subset of that. So use a foundation model like Florence 2, like SAM 2, to label data, or you can use any of the models in RoboFlow Universe as well. This is like one of the secrets that RoboFlow uses in training new models is there's already so many public models out there that have been trained for specific domains, whether it be anything from shipping container identification to fish detection. So you can use those models as kind of the start of an active learning pipeline if you don't have labeled data. Or the kind of more common use case is have one model that's trained and ready to go, consistently collect data that's running through your pipeline and run it through active learning, and then use that data to improve the performance of your model. Importantly, active learning involves collecting data from your production environment. That's essential because although a model that you find from someone else may sort of kind of work on your data, ultimately for the best performance, for 99% accuracy, for those moments where 0.5% of accuracy is essential for your use case, particularly common in manufacturing scenarios, getting that data from your production line is essential, especially as environments change too. If you've changed the lighting of your manufacturing line, your model may be subject to what we call data drift. This idea of, okay, you've got production data in your model, your production environment's changed, now your model doesn't do so well. So that's where active learning comes in. Now, one solution that we have for active learning is workflows. Workflows is all about building vision AI systems in a significantly shorter period of time. So I've mentioned a lot of technical words, active learning, data drift, collection criteria, among other things. That used to involve hundreds of lines of Python code, usually implemented by a professional computer vision engineer, and may involve using kind of integrating other models too. In short, it's a lot of work. With workflows, however, we reduce active learning and indeed running vision AI applications down to a single web-based user interface. The idea being that we give you all the components that you may need to build anything from the most simple application where you run a model all the way to the most complex where you're running 10 different models, whether it be foundation or production, you're running consensus, you're doing active learning. You can chain all these things together and deploy on your own hardware. So workflows is going to be the solution that we use today to build an active learning pipeline. So as I mentioned earlier, you can use active learning to bootstrap existing models. That could be a fine-tuned model in RoboFlow Universe, of which there are over 50,000 available, or a foundation model that we support. Currently, we have YOLO World for object detection, SAM2 for segmentation, and coming soon, Florence 2 by Microsoft. And this is kind of what this workflow looks like. It's a few blocks. We take in an input, run a foundation model, visualize the output so we can see what's going on, and then that data set uploads being fundamental, where we can send that data back to RoboFlow. And similarly, if we're improving existing models, collect production images using a workflow built in RoboFlow. This allows you to continuously collect that production data, feed it back into your system. And again, this is what that looks like. And instead of using YOLO World as we did in the last slide, we're using an object detection model. In this example, a yard management system where we run that model, we upload all the predictions back to RoboFlow, and we visualize it too. And those things are happening concurrently and and in real time as well. This could be deployed on a video stream, it could be deployed on live video or images. One of the most exciting parts is extending this. So workflows, every week we're adding new workflow blocks. You can visualize detections in many ways. You can transform detections, filter, apply conditional logic, and really anything that you need to build a production data application is either in workflows or will be in workflows in the coming weeks and months. So I've spoken a lot about kind of what workflows are and a bit here on deployment. A workflow could run on Raspberry Pi, AI PCs such as those from Intel, NVIDIA Jetsons, GPUs, really any hardware that's on your assembly line, on your production line, in the cloud, wherever you need compute, you can run your workflow. So with that, I'm going to get into a demo, which is kind of the more exciting part about working with workflows. So I am going to get started on this workflow here. So this is in RoboFlow Workflows. This is available to all users right now. This workflow takes in an existing object detection model, yard management, and we have this dataset upload block, which is what we call active learning. With this, in the optional properties section, up here, we connect this back to our yard management system. And so every single image that runs through this workflow is going to go to object detection and go to dataset uploads. And we can run this in the browser using run preview. So I uploaded an image earlier. I'm going to rerun this workflow though. Firstly, it's going to run that model. Secondly, it's going to plot the predictions. Thirdly, it's going to send it to our data set, that yard management one from earlier. And every workflow comes with this JSON representation, which is helpful for programmers who are working, systems integrators who want to build those seamless integrations between RoboFlow and your systems. And then we have this visual showing here's a fine-tuned model that already does quite well at detecting various different classes, logos, container IDs, the presence of containers. And if I go into that yard management data set in RoboFlow, we've got this one unassigned image from the workflow's data collector. And if I zoom out here and assign this to me for manual labeling, give it to my account, I can then go in here and review the annotations that came from that model. So using RoboFlow's suite of annotation tools, I can go in, I can check, okay, it got logos, it got the ID, all the classes are correct, great. And then I could approve this image, put it in my data set, and retrain a new model. So you can imagine this running in production where you maybe have a condition that only saves images if there is a detection between 50 and 60% confidence level. You can manually review all those, make sure they're okay, retrain your model, then very quickly change your model version. So in workflows, like if I go back to this workflow, changing the model that you're running is as simple as clicking on the model, changing the model identifier to whatever you need it to be. So as you're training new models and they become available, you can change them, deploy them on your hardware in minutes. Change it, save your workflow, it'll be available. So that's the kind of traditional active learning. And then briefly, the other one I spoke about was using a foundation model to label data. This is more bootstrapping an existing system where you might not have any data yet and you want to get at least a model started. You may do this concurrently with having humans label data, or you may do this to get a POC together to validate, is vision good enough for me? The problem with these foundation models is that they're huge. Running them in real time is sometimes possible, but often expensive. With RoboFlow, we give you the tools that you need to apply to active learning, label your data, and then maybe transition to that first workflow I shared, where rather than using a foundation model, you use your fine-tuned model, feed the data back into it. So in this case, I chose YOLO World to run a zero-shot model, and YOLO World is great because I can just give it a text prompt. So for that same use case of intermodal container, I can give it that text prompt. I can hit run preview. This is an image I put in earlier. Rerun the workflow. And this will take a few seconds because the foundation model we're using is bigger. And again, this is ideal for applications where you don't need to run in real time, but you're training that model. We've got our result back. In this case, we only got one class, which was the containers indicated by the purple boxes. And if I go to this other data set that I have, again, I have this unassigned image that came from workflows. I can go in, assign that image to myself, and then click through to that image and see, takes a second, and see we have our predictions. So we've got the intermodal containers that came from our annotation. But in this case, we used the foundation model, which came up with a wrong detection here. It got this mirror where there is a container labeled that as an intermodal container. So we can delete that. And we could refine these annotations as well. So maybe we want this bounding box to be tighter. We can go through all that, train a new model version. So in short, that's active learning with RoboFlow workflows. The fundamental premise being that we can use either foundation models to start building a new vision model, or we can use an existing model, collect production data, feed those images that have been passed through, those video frames, whatever it may be, and their model predictions back into our data set, then retrain a model. The benefits of this being, firstly, you gather more production data for your use case. You can prevent against data drift, where over time the distribution of your data shifts and your model may become less effective. And also, if your model is performing at, say, 80% accuracy, you're trying on a deadline to get models together, you can use active learning to quickly gather new data and incrementally improve your model up to the required level of performance. We see customers using active learning extensively for various different applications where, accuracy is essential. But we need a fast way to gather that data. So with RoboFlow workflows, what used to take hundreds of lines of code and a lot of expert knowledge and choosing sampling strategies and all those things is reduced down to choosing the blocks that you need in RoboFlow workflows, using workflows to test in that web-based interface, and then finally deploying your workflow from the workflows editor onto whatever device you want, whether it be a Jetson, a Raspberry Pi, an AIPC, T4 and A100 in the cloud, whatever hardware you have. So that's all I've got with regard to the active learning and getting started in RoboFlow. So I'm happy to take questions.